Hello guys, welcome to Cafe at Simplify, and here we are going to look at this last one and minimizing. And the question says a farm a farm has the following. Where this side a farm has the following demand function, which is given by here, and the following average cost. Here. Find the level of output that maximizes total revenue, minimizes total cost, and maximizes profit. We want to maximize total revenue, minimize total cost, and maximize profits. I think you see the difference here. I want total revenue, maximize it because the farm is benefiting. Minimize the total cost. Minimize what you can spend, but when you are still producing a good amount or the same amount, and maximize the profits. So since we have this equation, we don't know what P is. First make P the subject of the formula. After finding P, the average cost will, this is P, but this is SC. So we need to find the level of output which maximizes social revenue, minimizes the total cost, and all that we've talked about it. But to find TR equals to P times Q. We have our P multiplied with the Q here again. We will have 22 times the P, we get 22, times Q, we get 22 Q minus 0.5 times Q, we get 0.5 Q squared. I don't know if that is what we are having. We have this. Okay, yeah, it is here. So now after getting this one, now we are going to differentiate it. When you differentiate this is linear, it becomes 22. This 0.5 times 2, you get 1. So remain with Q. Now equate that to 0. So we find the critical value. And if it is positive, then that is the one which maximizes total revenue. Remember here, we are under maximizing total revenue, so we are not going to go into the differentiating again and all that. This point here, this value we get as our value of Q. After differentiating, equating to 0 is the what? Is the output which maximizes for the first time. Then minimizing total cost, we have our SC, average cost. This is already average, like all the costs have been added together and we have this. Now we have to minimize this. So we are given average cost. The total cost is calculated from when we get average cost times quantity Q, we get the TC. So we have multiply with Q inside and throughout this equation here. This Q and 90 will cancel with this and remain with 90 alone. If you take Q here, Q squared, then Q power 3, what we are having here. When we differentiate that for the first time, this cancels, remaining with Q squared. This becomes minus 17. This becomes plus 50 equals to 0. Quadratic equation, find the 2 points here. Now, since both values are potential critical points, we need to check the second derivative to determine which minimizes the total cost. So we have this quantity here and that quantity here, but both are what? Both are positive. So now we differentiate again. When we differentiate again, we're differentiating the first derivative. This becomes 2Q minus 17. Put again your critical value is 13 and it's 3.7 something. When you put them here, we realize that this one gives us a negative and this one gives us a positive quantity. This one means negative quantity. So since the second derivative is negative, this indicates a maximum at this one. So we wanted which minimizes total cost. total cost. So conclusion, the output minimizes total. The output that minimizes total cost is this one. Why? Because 13 gives us a negative. So that means now our total cost has been minimized. This 13 is giving us a negative. While so the output which minimizes is done from which gives us a negative. Then maximizing profits. What you should note when we want to maximize profit, we already have this TR equals to this, and the total cost function we have TR and TC. That's the profit function. Profit function we have this is the total cost, and now here we have total revenue. Now to get price, we are going to get this total revenue, because total revenue is the total of all everything minus the total cost minus what we spent to get the profits. I don't know if you guys are getting that, but to get the profits, you get the total revenue, you all the capital profits made, everything inside here, minus what you've spent to get the what? Profit. So that's why we have this. So this is from mathematics. You collect like terms. This negative will affect negative here. This negative will make this one positive. This negative will make this negative. This negative will make this negative. So when you open bracket, you can collect like terms. This and this 9, this 50, 20 minus this, and we get a negative 28. So after getting this equation, this is the equation for profit. So first derivative of profit, when you differentiate this one, the three cancels, we have a negative this. I think you guys, you are seeing that. You no longer need to explain much. Then equate it to 0 after differentiating. Find the two values for the profit. You get this and this. So we want to maximize profit. Find the second derivative of the first derivative. Then we get negative and positive. So now we pick in 14 and 2. When we put 14, we are getting with negative 12. This indicates maximum at 14. What about at 2? When you put a 2, you get our second derivative is greater than 0. And if it is greater than 0, this indicates minimum. So we go with this 14. So the output which maximizes profit is the one which gives us a negative under this situation. And so that is the conclusion.